Hello everyone. In this class, we are going to continue to finish the section 8.3. We are going to find an annihilator for other cases for when the R is complex number. Okay. So firstly, let's see. We can say this is case 2. For functions like e to the ax cosine bx, e to the ax sine bx. Okay, and here a, b are real. Let's see what's the annihilator for them. So that means what? That means R should be a plus minus bi, right? Complex number. So what is PD? That means d minus, if we look at the original differential equation, so it should be d minus a plus bi like this times d minus a minus bi, like two solutions, right? And y equals 0. Okay, this should be the solution to this differential equation. And now we simplify this one. So let's see. Okay, after we simplify, okay, d squared is going to be, and the sum, the middle term, like should be the sum of those two numbers, so it should be 2a. Is that right? And so it's kind of like d minus 2, d plus 3. How do you expand them? D squared. So what's the sum term? Add those two numbers. So plus d and negative 6. And this is the product of those two, right? So product of those two numbers should be a squared plus b squared. Okay. A squared plus b squared y equals 0. So AD equals d squared minus 2ad plus a squared plus b squared. This is the operator that annihilate both of the functions. Those functions. So let's see. Those functions are e to the ax cosine bx, e to the ax sine bx, and also include the sum of those two functions. F equals, if we factor this out, so cosine bx plus sine ax bx. Because AD can make each of them into 0, so if definitely can make the sum into 0, right? If we do the operator to those functions. And a special case, if a equals 0, so when is equals 0, for example, when d equals 4, like this one, right? A equals 0, because for this case, r equals, plus or minus 2i. In that case, a is 0. So what is annihilator? D squared. So let's see, the middle term a becomes 0 and a squared becomes 0, so just d squared plus b squared. So sorry, this should be dA. AD. Okay, so in special case when a is 0, this one. Definitely more general, if we like have some power x to the k power in front of ea cosine bx and e to the x sine bx, so that so AD equals what? D squared minus 2AD plus a squared plus b squared. Okay, so right now k plus 1 annihilates those functions. So it should be x to the k e to the ax cosine bx and x to the k e to the ax sine bx. And also, okay, let me write down in this order. I'm going to write down this, start from the lower one. So e to the ax cosine bx, x e to the ax cosine bx, x to the k e to the ax cosine bx, like this. And similar, we have a pair like sine bx, so e to the ax sine bx, x e to the ax sine bx, no. And x to the k e to the ax sine bx. Okay, let's see. And the number 4 case, if f is the sum of the functions from the form given in 1, 2, 3, okay, then fx is annihilated by corresponding product of the annihilators in 1, 2, 3. So by the product of the ADs in 1, 2, 3. I'm going to give you several examples. It look complicated, but after we do more exercise, it's not difficult at all. Okay, so let's take a look at this one. If we have x e to the 2x cosine x, look at this one. How to find the AD? Firstly, we need to tell what is A, what is B, right? So A should be 2 and B equals 1. If we don't look at the x, so that's going to be something power, okay? Depends on the multiplication. So here should be d squared minus 2ad, so minus 4d, and plus a squared plus b squared, so 4 plus 1, which is 5. Because x in front, so here's power 2. Okay, so this is how we find ad. Let's take a look at another one. If I just give you e to the 3x times sine 4x, let's see, what is AD? So AD should equals to, the formula is d squared minus 2ad plus a squared plus b squared. Okay, so what is A? A should be 3, so minus 6d plus a squared plus b squared, so which is 9 plus 16, so which is 25. Just like this. And because there's no x in front, if there is x squared in front, and here we do the power 3, k plus 1 power. So just something like that. Now let's take a look at the example. Okay, example 4. So this is also differential equation, non-homogeneous, and the right side has sign. Okay, solve the initial value problem. And this one means we have differential equation, and also we have initial conditions. And the initial conditions are y0 equals 0, y prime 0 equals 1. So usually we use the initial condition to find the C1, C2, like the general constant, the arbitrary constant. Okay, so firstly we have the differential equation, but at the beginning of the class, usually it's given by P dy equals F, right? So first step, we want to change this into this form, P dy. Let's take a look at the differential equation. Second derivative, that means d squared, and first derivative means d, and minus 2, and y equals 10 sine x. Okay, and we can further simplify because we need to find the homogeneous solution yh. So we factor this out. D minus 2, d plus 1, y equals 10 sine x. So what is yh? C1 e to the 2x plus C2 e to the negative x, because for those two right? For those two, we find the general solution to the homogeneous differential equation. Next step, we need to find annihilator. So AD equals what? Okay, so AD, we need to look at the right side, sin x. For the sin x, that means A equals 0, B equals 1. Is that correct? So in that case, it's going to be d squared plus b squared. Do you still remember the special case? You can also plug in d squared plus 2ad plus a squared plus b squared. But you know, because a equals 0, so it's just d squared plus b squared. In this case, it's going to be d squared plus 1. So let's annihilate sin x. Okay. That means can make sin x into 0. So we put this multiple AD on both sides of the equation. So we have d squared plus 1. And we still have d plus 1. So y, and the right side becomes 0. Because that's the annihilator. That's how we want the right side to be 0, right? So that's why we choose d squared plus 1. But we noticed when we get the new differential equation, we can combine those two. So, no, we cannot combine, sorry. Okay, we cannot combine. Now let's write down the general solution to this one. Okay, you can refer 8.1. How to write down general solution? Y equals, I'm going to write down the solution corresponding to like YH, okay, YH. So which is C1 e to the 2x, C2 e to the negative x, and the corresponding to d squared plus 1, we have sine cosine. So, but here we don't do C3, C4, I'm going to use A0. Okay. You can do the other that matters, cosine x, sine x. And here we do, you can do A and B. Here I use A0 and A1. A1 sine x. Okay. So from here, can you see what's the particular solution? If we don't look at, just get rid of the general solution. So because this is the YH, so this is YP, right? So let's write down the YP. YP equals A0 cosine x plus A1 sine x. This is different from the previous examples because for the previous example, we only have one undetermined coefficient, but here we have two. But that's fine, we just plug into the differential equation. We can find the A0, A1. We can determine those coefficients. Okay, let's see. Firstly, we need to take the first derivative, second derivative, and this is easy to find. Should be sine A1 cosine x. Second derivative, cosine x minus A1 sine x, right? And plug into our original differential equation. Where is our original? Plug into d squared minus d minus 2. Y equals 10 sine x. Okay, something like this. And let's see. Second derivative, copy. Second derivative, and then minus first derivative, and minus here. I'm just going to put parentheses here. Alright, minus first derivative, and then just minus 2 times y. And the right side is 10 sine x. Let's see. Now we are going to combine all the sine term and all the cosine term on the left side. In the left side. So let's see. Cosine term here, one cosine, cosine, and cosine. Let's combine those. So it should be negative A0 minus A1 minus 2a naught cosine x, right? And next we combine the sine x together, so which is here sine, sine, sine. So should be what? Negative a1 minus a, okay, plus a naught and minus 2a1 sine, and the right side is still 10 sine x. Okay, so let's see, because so right now we get two equations. The right side there is no cosine, that means the cosine coefficient should be 0, and we can simplify them. That means negative 3a naught minus a1 equals 0. And if we look at sine coefficient we can also simplify. So a naught minus 3a1, the right side equals 10. So we got what? We got two equations, two unknowns, and those two unknowns are a1 and a naught. And we can solve them easily, right? We already learned a lot of ways to solve. So you can use Cramer's rule, you can use back substitution, or you can use elimination. This is 2 by 2, so pretty easy to solve. But after we solve them, a naught equals 2, negative 3, a1 equals 1. So our particular solution equals to a naught negative 3 cosine x. Okay, so here opposite. So this should be 1, negative 3. Negative 3 sine, so the answer should be negative 3. Just plug into the particular solution, says x. Okay, so what's our general solution? C1 e to the 2x, C2 e to the negative x, and then minus 3 sine x plus cosine x. Okay, but we have initial condition. Initial condition, we plug in y0. So we get C1 plus C2 because all of them equal to 1, right? And this becomes 0 and this is 1 and the plus 1, which is given by what? Which is given by y0 equals 0. And then plug into y prime. Y prime we need a little bit, we need a y prime here. Negative x, 3 cosine x minus sine x. Okay, y prime 0 equals what? 2c1 minus c2, and 0 here plus 3, and initial condition is 1. So what we get here? Okay, so we get 2c1 minus c2 equals negative 2. And then combine with the other equation, which is c1 plus c2, which is negative 1. We can solve for c1, c2. We can add those two together, so we can solve. C1 is negative 3. Plug in. Sorry, when we add those, so it's going to be 3. C1 is negative 3. C1 is negative 1. C1 is negative 1. And what is C2? C2 equals 2c1 plus 2, so it should be negative 2 plus 2, should be 0. Is that correct? Negative 1 at, yeah. Okay, so the solution that satisfies the initial condition should be C1 e negative 2x, and C2 is 0. So the solution just be like this. Okay, and we can try the exercise. Let's see. A little bit easier, so let me give you this one. Here's the solution. Firstly, write down operator way. Okay, and the general solution to this one should be YH C1 cosine 2x, C2 sine 2x, because corresponding to that one. R equals plus minus 2i. Next, find annihilator to the right side, which is d squared plus 1, because a equals 0, b equals 1. And then we times this to both sides of the equation. Y equals 0. Then we find the general solution to this one. C1 cosine 2x, C2 sine 2x. Okay, and then going to be particular solution. You can do A and B. Okay, if you like A and B, that's okay. Cosine x plus B sine x. And this is our YP, right? So let's write down our YP. Next, we need to find the A and B. So next, find A, B. How? Plug this into original differential equation. And before we plug in, we need to find the second derivative. So negative A sine plus B cosine, and negative A cosine minus B sine. Is that correct? Okay, and then we plug this into which one? Original differential equation, which is d squared second derivative. So cosine x minus b sine x plus 16 y is a cosine x plus 16b sine x. And the right side equals 4 cosine x. And then we find two equations with a and b. So if we look at cosine, so cosine term, so should be 15a cosine, right? So if we just look at the coefficient for the cosine, so 15a equals 4. And then for the b, for the sine, so that means 15b equals 0. So that means what? A equals 4 over 15, b equals 0. So our particular solution should be what? A cosine, so cosine x, and then plus 0 because b is 0. So the general solution should be C1 cosine 2x, C2 sine 2x, and plus YP, which is 4 over 15 cosine x. Okay, this is how we solve the differential equation. Now let's take a look at example 5. Find the general solution to this differential equation. Firstly, we noticed we want to find the general solution to the homogeneous, so that means for the left side, right? And we want to factor this out. Usually, we want to factor this. But when we look at this quadratic polynomial, we cannot factor this out. Actually, for this one, b squared minus 4ab, which is 16 minus 20, which is 94 less than 0. That means this one has no real solution, only has complex solution. Okay, complex solution. And we can leave this right now. Okay, right now. And let's take a look at the right side. Let's take a look at AD. You can find the complex R right now, but let's find AD for the right side firstly, and then come back. Let's see. For this one, if we don't look at the x, so for the x in front, we should have something square for this x, right? We should have square thing. And for A equals 2, B equals 1. So here should be D squared minus 2AD minus 4D, and then plus A squared plus B squared, which is 5. This is AD for the right side. Okay, AD for the right side, capital F. And we use this times both sides. So that's interesting. This is the same as our beginning, the left side, right? So let's write down this. So we times AD on both sides. So we times AD on both sides, right? So here should be square, and right side becomes 0. Simplify d squared minus 4d plus 5 to the cube power y equals 0. Now let's write down the solution to this one. We know corresponding to this one, we should have e to the 2x cosine x, e to the 2x sine x, right? Because we get this from the right side. We know a is 2, b is 1. But because we have cube power, that means we should have x e to the 2x cosine x e to the 2x sine x. And also we should have x squared because it's a cube power, x squared e to the 2x cosine x. And here x squared e to the 2x sine x. And let's write down the general solution. So we should be linear combination. And because original differential equation just has power 1, so this is like the general YH, the solution to the homogeneous. So the left thing, we do like A naught plus B naught plus A1 plus B1. Okay, so this whole thing is going to be particular solution. I know it's a little bit long, but we have to do this way, okay? So YP equals A naught x e to the 2x. Just copy. B naught x e to the 2x sin x. E1 x squared e to the 2x cosine x plus B1 x squared e to the 2x sin x. And we plug this into original differential equation and solve for A0, A naught, A1, B naught, B1. Okay, and after we solved them, we get actually this. A naught, A1 equals B naught going to be 0, and A naught equals 2, which is B1. So the final, like the particular solution, going to be this 2x e to the 2x x sin x plus cosine x. So the general solution to the whole differential equation is going to be general solution to the homogeneous plus the particular solution. So here we skip the calculation of this part, but if we plug this into the original differential equation, okay, we should get 4 equations with 4 unknowns, 4 equations, 4 unknowns, and we can use matrix to solve those 4 unknowns. Okay, and here's the solution: A1, A naught, A0, A1, B0, B1. And this is it, example 5. Let's try. Let's see. Let's try to find in AD. Find AD for the following functions. Okay, because that's the most important part, right? The first step actually, or second step. Fx equals sine x plus 3x e to the 2x. The first one. We can do this as example 6. So let's see. If we look at this first case, let's see, case 4. If f is the sum of functions, then AD is product of the corresponding annihilators. Okay. Let's see. For sine x, we know this should be d squared plus 1. Is that right? And for this one, what's the AD? It's going to be A is 1, B is 2, so it should be d squared minus constant. We can skip the constant because constant doesn't matter 2a, so 2d, and plus a squared plus b squared, so it should be 5. So it's going to be product of those two. Okay, so this is the first one. Now let's take a look at the second one. If the f equals this thing, 1 minus 3x e to the 4x 2x squared. So let's see. For this, the first part, you can look this as e to the 4x minus 3x e to the 4x. The annihilator to both of them going to be d minus 4. But because x here, we do square. So this and annihilate both of the functions. And the next, okay, so it's going to product times. What's the annihilator for x squared? X squared, that means, do you still remember? That means x squared times e to the 0x. That means a is 0. In that case, it's just d, but x squared is going to be d cubed. Okay, let's take a look at number 3. E to the x sine 2x, 3 cosine 2x. For this case, AD, for the first function, that's going to be d squared minus 2AD, A is 1, and plus a squared b squared, which is 5. And for the second one, so should be d squared plus 4, right? And it's going to be the product of those two ADs. So number 4. X cubed e to the 7x 5 sine 4x. We can do this as exercise. You can try. If f equals this one, what is AD? Corresponding to the first one, so should d minus 7 to the power x cubed in front, to the fourth, right? And times d squared plus b squared, which is 16. Something like that, okay? So this example gives us most of the way to find the AD. So let's try the last example. Actually, it's duplicated with previous examples, but we just want to do as small as possible. I know this may be difficult to some students, but it's just calculation. If you understood the procedure, it's not difficult at all. Let's take a look at the right side. What is AD? AD should be, okay, d plus 1 because e to the negative x. And because x in front, we do square, right? And times the right side, d squared minus 2ad, 4d plus a squared plus b squared, so which is 4 plus 9, which is 13. Okay, so this is the annihilator to the right side, capital F. So we times this on the both sides. Okay, so we use this times both sides of the equation, d plus 1, d squared plus 9y, and the right side becomes 0. And let's write down the solution. Before before I write down the solution, I think we can combine those two terms. We can change this into d plus 1 cube, right? And d squared minus 4d plus 13 and times d squared plus 9. Okay, and corresponding to the original homogeneous differential equation, we can write down the YH firstly. I like to write down YH in front, so the left thing will be just particular solution. YH should be, let's see, e to the negative x, right? And we have cosine 3x, sine 3x. That's the general solution corresponding to the homogeneous. Okay, and right now, let's look at this one. We should have more terms. So corresponding to d plus 1 cube, we should have x e to the negative x, x squared e to the negative x, right? So we can do a not b. We can do a and b, and corresponding to, let's see, corresponding to that one, this should be, and then we get this from what? From this term. So we know we should have that kind of form. E to the 2x cosine 3x. So you can do c d sine 3x. Okay, and what's the particular solution? Because this is YH, so particular solution going to be those four terms, YP. Okay, so for this one, just find YP. YP is also called trial solution. Okay, so we don't need to solve, everything. Just to find YP because it's pretty complicated. YB x squared e to the negative x, c okay, so that is a particular solution of YP. Okay, we can stop here for this section. Let's have a quick review of the summary, what we did. Firstly, we need to know how to find AD annihilator. So AD means what? Means AD can make the kind of function, usually the homogeneous function, non-homogeneous function, the right side, capital F into 0. And we need to, and here we have several cases. Okay, several cases. When D is real, for example, I just give you an example, okay? X squared like e to the 4x, like this one. What is AD? AD should be D minus 4. And because x squared there, so it should be cube power, right? Definitely is also annihilate the same thing. Something like this. And second case, if we have e to the 2x, like a sine 3x, this kind of thing, and I'm going to add x in front. What is AD? AD equals d squared minus 4ad plus a squared plus b squared, 4 plus 9, 13, and because we have x in front, so square. And if we have the real, like a, okay, let's have a quick review, x squared and plus maybe just cosine 3x. What is AD? AD is going to be product of their annihilators, okay, corresponding annihilator. For x squared, so it should be d cubed and times d squared plus 9. Something like this. Okay, first we need to know how to find AD. Second thing, we need to know how to solve PDY equals F what we do, we times AD on both sides, make the right side equals 0, and then we write down our y as YH plus YP, and we find YP. Third thing, determine the coefficient. So determine coefficient in YP. Sometimes YP has one coefficient, but sometimes it may have several coefficients. But we just plug in YP into, so how to do that? Plug YP into differential equation, solve for the coefficient. Okay, solve the coefficients. That is called undetermined coefficient. So for this kind of problem, we just need a lot of practice. It's just calculation, nothing difficult, and this definitely is going to be in the final. We can stop here for this section.